Hello, and today I will be presenting and discussing question 2, which is the formation of isopropanol from ethanol and methyl magnesium bromide in diethyl ether solvents in an acidic environment. It is an example of a nucleophilic addition reaction, and the nucleophile used is an example of Grignard's reagent, as it forms a carbon-based nucleophile, and are useful in extending the carbon chain and adding alkali groups to the molecule. As I've drawn and done my best attempt at the moment, this is the best you're going to get. Me and my cat Meow worked on it. So if you think it's wrong, then better luck next time. Such a shame that I might have done it wrong, but it is my best attempt, so please don't go hard on me for this. So as you can see, the methyl anion is formed and it acts as a nucleophile, as it's highly attracted to the electrophilic carbon on the carbonyl group, as it's very electropositive. The nucleophile will attack the carbon, called it the nucleophilic attack, as a methyl group will attach to the carbon bonded to the carbonyl group. Then a tetrahedral intermediate will form, called an alloxide ion, which has an oxygen that's negatively charged. It is not forming enough bonds, therefore it will act as a nucleophile, whilst the proton released from the acidic environment will act as an electrophile, and it will attach onto the oxygen, and it will react with it. This will then form a hydroxyl group, and the end product isopropanol will form. And next slide. In terms of electron movement from orbitals, first step, electrons from the methyl anion, there is an active lone pair which will attack the pi star antibonding orbital in the carbonyl group, as it has the lowest energy orbital, which is where electrons want to go. The electrons then enter the pi star antibonding orbital, which will cause the pi bond to break, and therefore the tetrahedral intermediate will form, the alloxide ion. Therefore, the proton present will receive the electrons from the pi star orbital to the bonding 1s orbital on the proton, forming a sigma bond between both atoms. Therefore, the end product is formed of isopropanol. And the last step, electrons have all transferred to the right orbital, and the reaction is completed to end with your end product 2-propanol. I don't know why I did this slide. I think I did it so I could get to make a longer video. Oh look, a reaction coordinate diagram. This shows the energy changes during the chemical reaction. The highest energy state is the transition state. I don't have a structure for this because I don't think I know it, because I don't think you can isolate a transition state. So you can just use your imagination and think of something really unstable and high energy, and then you can complete whatever image you were hoping for in your head, because I clearly don't know the structure. Then we have an intermediate state, which is a alloxide ion, also high energy but not as high energy, and you can actually isolate it and see it, and it's the alloxide ion. Then our products, lowest energy, very stable, amazing and great, it's isopropanol. And the last part of our question is oxypentanol reacts with methyl magnesium bromide in diethyl ether to give one single organic product in high yield. I got this structure. It looks like a diol because I think 2 nucleophilic addition reactions happen. One at the ketone group on the 4th carbon and one on the aldehyde group on the 1st carbon. So that's my prediction. If it's wrong, live, laugh, love, because at least I used my mind and I got something to show everyone. And I think it's pretty good because I tried. And my explanation is the product D is this because two nucleophilic addition reactions have occurred, one to the ketone group and one to the aldehyde group at the end, therefore forming a diol and the addition of a methyl group due to a carbon-based nucleophile being used in this mechanism. And you know what? That is the end. And have a happy new year and Merry Christmas. And if you have a cat, meow. And hope you liked my presentation because I sure had a great time doing this and it was a highlight of my week. Have a good day. Bye.